Oh, hi, welcome. This is pre-lab lecture for Titrimetric determination of KHP in an ensemble. I'm going to walk you through on how to determine the mass percent of KHP, and I'm assuming that you have collected the data, you have done the um, or you have determined the RR value. Allow me to share the Word document and my whiteboard so that you can see the calculation. This is the Word document which I used to in sample calculation, determination of KHP. This is the equation, KHP reacting with sodium hydroxide to form H2O, and the mole ratio here is 1:1. If we focus on the reactant side, this is the chemical formula for KHP with a molar mass of 204.2 grams per mole. In the first part, we will standardize NaOH using KHP, which is the primary standard. And as I said, the assumption here is that you have determined the R value. This is for pack titration. I'll walk you through the concept of pack titration. You should use at least 1 ml of ACL in pack titration. Now let's see standardization of 0.1 molar NaOH. The target or the objective in preparation of our titrant, which is 0.1 molar, is that you are to weigh between 0.700 grams to 0.8 of the standard KHP. This is the standard KHP, and the standard KHP was dissolved in 75 to 100 ml deionized water, and these are the two indicators used, either phenolphthalein or thermal blue. For phenolphthalein, changes color from colorless to pink at the equivalent point or end point, or if you are using, or if you use thermal blue, change color from yellow to blue at endpoint in titration. So part A, you are to weigh pi difference. This mass given here was pi difference, and if you look at the lab notebook organization, you should have the mass of, all right, let me just fast forward to see where the lab notebook organization should look like in terms of the mass of KHP for trial 1, trial 2, trial 3. This is the lab notebook organization. We're going to come back to pack titration. This is for pack titration, but here is the standardization. So the file plus the total mass of KHP after drying minus the KHP. In this case, the KHP you are removing is this range given here. The apparent mass is what the actual mass you do it, which you dispense in each one of them, trial 1, 2, 3, and 4. So this is what trial 1, trial 2, trial 3, trial 4, each one with dried KHP. This is the apparent mass. Purity factor was 99.9%. 99. The purity factor here is 99.99. Now the actual mass here is obtained by multiplying the apparent mass by the purity factor. Let's assume in beaker number 1 here, this is the mass of KHP. This is the apparent mass determined by wing by difference. If we want to find the actual mass, it's the apparent mass times the what? The purity or the purity factor, which is 0.999 times the actual mass, which is times the apparent mass. Purity factor times apparent mass, this is what you get. Now, this is what we will use to find the number of moles. This is the mass, actual mass in beaker number 1. In beaker number 1, you see here. So how are we going to proceed with the titration? With a calibrated puree, you have to indicate which puree you are using because you will refer to the calibration curve. With your setup, you see the meniscus is at 0,0. This is a 50 ml calibrated standard A or puree A. You should have its calibration curve ready. So you will continue based on which standard or which indicator you're going to use. After the titration, you will see, or you may have noticed the color change from colorless to pink, or from yellow to blue if you are using thermal blue. Assuming that in this mass, this is the amount of NaOH used to over titrate to see a pink color if you're using phenolphthalein. This is what we will pack titrate to go back to the original color. So let's see how many moles. You need to know the moles of what? Moles of KHP in sample number 1. We are still working on sample number 1. This is the number of moles, and just using the molar mass as a conversion factor. I know the number of moles I do have in trial one. So after titration, this is what I have in period A. To back titrate, let's see, back titrate to go back to the original, this is what's going to happen. In period P, calibrated period P, you need to do what? Add HCl to about what? It's recommended 1 ml. I'm just picking 1 ml here for the sake of calculation. The volume of NaOH from the first titration, final minus initial. This is the apparent volume for NaOH, which in this case, you will fill in puree B. If you're using B, volume of not B but A, sorry, this is A for NaOH. We have here this is NaOH, of which we don't know what. We don't know the molarity at this point. So here I should have initial 0.00 and final is 28 ml. I just pick up this and it's over titrated. Now to pack titrate, you will move this flask with over titrated under puree P with HCl. Add dropwise carefully until the color goes back to colorless. Record the final volume of HCl used. This is where you had to indicate initial and final volume of HCl right here. This is where you need to indicate HCl used for pack titration. The first one here on the data sheet was for what? This is for calibration. This is for factor iteration. So we don't worry about that. So let's see. We go to the volume of HCl. That's what we're gonna have when we do it. When we have the I don't know where the volume is coming from. Let's see.